Good evening, Professor. My name is Victor, and this is my evidence number 2. Our project consisted of simulating the functionality and operations of an industrial curtain. We sketched up how the system would work. We chose all the sensors and actuators we would use in our solution and how it would work. As far as tools go, we used Logisim. It's a simulator to design logic circuits. And also we used LabVIEW. Is a way more advanced simulator. It's way more advanced than Logisim. It's kind of a Logisim on steroids. And it allows you to do even more than just sketching the circuits. You can actually use blocks and make it look a lot more sophisticated. Now, we first investigated the competition, the solutions that are currently in the market. We found a bunch of solutions, but the one we picked as our role model was a solution from a company called Vector. Their model is the Alurol. It's an aluminum curtain, which is a lot harder than plastic. But what we found is was very sophisticated. It was a very sophisticated system, very nice functionality, but also it was very expensive for what it was. We personally, I think, and my team also thinks that it was very expensive. We contacted the company and they priced us a 234,000 Mexican pesos with installation. Obviously, they come over to wherever you want to install it and they do it for you. But 234,000, that is a lot of money for what it is. It doesn't matter how sophisticated it is, it's a lot of money. Some companies can't justify you spending that much money on what it is, a door. It's technically a door, but it's a little more advanced because it can work automatically or in a manual override. So we started from there. We wanted to do a system just as sophisticated, but a lot cheaper. So we started with the logical process. We found 3 input variables. We have object detection sensor A. We have a position sensor for the curtain. It is called position top, which means a open position, a fully open position, and the third sensor is for a fully closed position. The first input, letter A, the object detection, is going to be a logical 1 when the sensor picks up an obstacle. If it doesn't, then it will be 0. The first position sensor, it's going to be for the fully open position. It will be a logical 1 when the gate is completely open, and is 0 if it's not closed. Well, if it's anywhere not in the fully open position. The last sensor is going to be the fully closed position. Is going to be 1 when the curtain is fully closed, else is going to be 0. And for our output variable, we chose the movement of the curtain when it's either opening or closing. It's going to be a logical 1 when it's moving, else is going to be 0. Now, we started by optimizing the circuit. Although our previous circuit is not very complicated, doesn't use a lot of components, any optimization is welcomed. So we proceeded to do a Cornejo diagram, and we came out with this equation. We input this equation into Logisim, and we tried using more basic logic gates with 2 inputs and 1 output. We used 4 AND gates and 1 OR gate. As we can see, we have our 3 input variables all of our gates, and the last output variable. Now, how will our system work? We have our obstacle detection sensor that is going to be active when our curtain is in the automatic mode. How do we switch into that? In the controls, we have a mode control, which is a switch that you can toggle between automatic mode or manual override mode. When you're in manual mode, you can use the up and down buttons to operate the curtain, to open it or close it. There is another button, which is the stop button. This is gonna always be available. It's an emergency stop. It's not something you would want to use periodically. What it does is it will cut the power to the curtain at any given moment, given the condition that you physically press that button. Maybe the curtain is in automatic mode and the obstacle detection sensor fails and there's something in the way of the curtain either opening or closing, and the curtain is about to close over it or crush anything that's in its way. So this button will allow you to stop the curtain at any point. Now, in the design process, we didn't encounter many major problems. The only real issue or problem we found was sticking to our main idea of keeping it within a budget. We wanted to do a solution that was as economical as possible, but still innovative and very functional. Being innovative requires ambition, and something too ambitious generally drives up costs, and we wanted to keep those as low as possible. So my role there was kind of being the killjoy of the team. I don't like being that kind of person in a team, but somebody had to do it. So I made sure that if anything was way too ambitious, I made it ambitious enough to stick to our budget. Instead of cutting corners into the expensive one, we chose to build up to it. That was it for my presentation. Thank you very much.